You know, Paul, I always thought that eating chicken was, well, just eating chicken until I found out that some dinosaur detectives think that chicken, like all birds generally, are dinosaurs. That's a pretty amazing thought until you think about all the clues they've picked up so far.
Really?
Really?
Well, when did it start?
Well, it started quite a long time ago, back in 1861, in a quarry in Germany. Some workers found a small dinosaur and the perfectly preserved impression of a feather. The feather that was found in southern Germany caused an uproar. The 19th century fossil hunters, dinosaur detectives, were confused, for the feather should not have been there at all. The limestone rock dated back to the age of dinosaurs, millions of years before birds were thought to have evolved.
I think it was a real bombshell when this feather was found. You can imagine it was only 2 years later, after Charles Darwin had published his book on the origin of species, founding his theory of evolution. And in 1861, a single bird feather was found in these quarries in the Solnhofen lithographic limestone.
Searching frantically for more evidence, the fossil hunters soon found a second clue. But this only turned the puzzle into a mystery. The experts were thrown into total confusion when close by the feather, they found the complete skeleton of a small bird, or they thought it was a bird. They called it Archaeopteryx, ancient wing.
And this was even more exciting because it showed both reptilian and avian characters. And there was, of course, a debate which one it was. Was it a reptile with feathers, or was it a bird, despite its reptilian skeleton? And this caused a great and sometimes dramatic argument among different scientists, because it turned out that it really was a missing link between two classes of vertebrates, between the reptiles and between the birds, and showing evidently that there must have been a transition between these two reptiles towards birds in evolution.
For decades, dinosaur experts could not decide. Was Archaeopteryx a bird with teeth or a reptile with feathers? Was it a freak of nature or a new insight into evolution? The feather and the skeleton remained a mystery.
It really is an enigma in many respects. It shows, for example, along the forelimb here, 3 quite prominent, sharp claws. You don't associate those with the wing of a bird. If you look at the tail, back here, you see there's a bony spine. Those 2 features themselves are very typically reptilian. Also, if you look at the head of the creature up here, you can follow along the line of the jaws these little spiky teeth. These 3 characteristics are not typical of those of birds. The long, bony tail, the dinosaur-like claws on the hand, the teeth in the jaws.
From the time of its discovery until the mid-1970s, Archaeopteryx has been regarded as a linchpin in the evolution of birds. The problem was identifying precisely which group of reptiles was closest to Archaeopteryx and therefore to birds. In 1973, the problem was looked at afresh by a modern dinosaur detective, John Ostrom. Starting at Solnhofen, where else, he looked again at the clues.
Oh, well, it has such beautiful fossil material from that very fine-grained lithographic limestone. And it's almost like photographs of things that once lived in a lagoonal kind of setting 150 million years ago. That exquisite material. It's a glimpse into the past that I don't know of any other place that produces such wonderful, wonderful material. I see the rock record as a vast library, but most of the pages are blank. There are pages that are just full of information, like the Solnhofen limestones have produced for us. My fieldwork expeditions has been tracing down blank pages because there have to be pieces of information on those blank pages that simply haven't been discovered yet. And I've been very fortunate in finding some evidence on some of those blank pages.
The mine in Bavaria has filled in some of the gaps. Because the lagoon in which the feather and skeleton were preserved is unique, the remains of Archaeopteryx and other creatures are perfect in every detail.
The nature of the preservation we find in the Solnhofen material, it's exquisite. One of the most remarkable of all finds, of course, are those specimens of Archaeopteryx, in particular the Berlin specimen, which shows such beautiful detail of the feather imprints. It's remarkable, a kind of photographic image almost that is preserved from 150 million years ago.
Only 6 skeletons of Archaeopteryx have been discovered over the years. One found in 1951 has a most curious tale to tell. It is kept under lock and key at Eichstätt Castle in Bavaria. It held a clue to dinosaurs as the ancestors of birds. For 25 years, this specimen was classified as the dinosaur Compsognathus, simply because it had no feathers preserved around its skeleton. Was Archaeopteryx really a missing link between dinosaurs and birds? A crossover point at which the dinosaur family split, and one line, millions of years later, became true birds. Our detectives are still examining the evidence. To get more clues, Peter Wellnhofer has made a cast of this fossil, and by coating it in gold, he can examine it in detail under the electron microscope.
One of the most striking features in Archaeopteryx is that it has teeth, and these are in fact reptilian teeth. I'm trying to compare the teeth of Archaeopteryx with the teeth of Compsognathus. Compsognathus, of course, is a small dinosaur, which is supposed to be closely related to Archaeopteryx.
The small dinosaur Compsognathus may hold the key to Archaeopteryx ancestry. Could it be a close relative?
Well, if you take a quick look at the anatomy of something like Compsognathus, this nice model, which is actual size, and you look at the anatomy of Compsognathus, or as you see it preserved in that fine specimen, compare that with the skeletal remains in Archaeopteryx. And there are so many skeletal details that one has to conclude, I think, that they came from a common ancestor. They evolved from the same source of a small dinosaur of this general kind.
Without those feather impressions, it would have been impossible to actually say that this was a bird, because if you look simply at the skeleton of this creature, the skeleton is that pretty typically of a little carnivorous dinosaur.
The bird-dinosaur nature of Archaeopteryx prompts other questions. Could it fly like a bird?
The main feature which distinguishes Archaeopteryx from other dinosaurs is that it's got feathers. And we think they acted aerodynamically. Now, if you look at the feather of a modern bird, like this swan, and compare it with the feather of Archaeopteryx, you see exactly the same structure. Central shaft with veins radiating off it. What's most important, the shaft doesn't run down the middle of the feather, it runs slightly off to the side. That means the feather aerodynamically is optimally designed. There's no reason for Archaeopteryx to have a feather like that unless it flew. I wouldn't want to say Archaeopteryx is definitely an ancestor of all modern birds, but it is the closest specimen we've got to that lineage. Archaeopteryx itself may have been a dead end, but on the other hand, there would have been animals probably quite similar to it, which weren't dead ends. And the sort of changes which had to happen would have been a loss of the bony tail, further reduction in weight, like thinning the skull, losing teeth, losing anything which is unnecessary, like the claws on the forelimbs. When we get to the next fossil birds after Archaeopteryx, all these changes have happened.
I like to think of it as almost a snapshot in time, of course, evolutionary change in the act of changing.
Evolution caught in the act? Archaeopteryx is got to be the nearest we've got to what is effectively an evolutionary missing link. It's lying very, very close to the borderline between what is effectively a true dinosaur and what is perhaps one of the earliest known birds. Archaeopteryx is the nearest we'll ever get to catching evolution in the act.
Dinosaurs did not really become extinct. They left their offspring, and these are the birds, and it's some kind of happy feeling to see birds flying over you and regarding them as dinosaurs.
The link between dinosaurs and birds, first established in Germany and developed by men like John Ostrom and Peter Wellnhofer, is worth celebrating. Dinosaur detectives don't find missing links every day, but as they toast, other investigators are proposing even more radical ideas. In America, some now suggest that the most fearsome meat eater of all time, T-Rex, is closely related to a bird.
Bob, where do you stand on this bird-dinosaur link controversy?
Well, I stand with Thomas Henry Huxley, who in 1868 said that birds are the direct descendants of dinosaurs. What he pointed out, still true today, you look at a meat-eating dinosaur like Tyrannosaurus rex, and the hind foot looks like a bird. It's got 3 toes that face forwards, a little toe in the back, short torso, curved neck, short but strong front legs. The overall gestalt is like a bird. But now we have a lot more evidence. If you look at a bird head, this is an ostrich, okay, it's the eye socket there, and you look at how the jaw attaches to the head. Well, it attaches right there, and there's a pair of grooves that are oblique. They go inwards and forwards, and lower jaw slides when an ostrich bites, slides. There's only one type of prehistoric animal that has a sliding jaw joint like that, only one. That's the big meat-eating dinosaurs. Okay? So there's a detailed mechanical resemblance between a dinosaur and a bird. This gigantic jaw could slide backwards and forwards just like a 4-foot-long ostrich jaw. But the thing I really love is most people think of birds as delicate, and Tyrannosaurus rex is rather big and crude. It's not true. Tyrannosaurus rex is incredibly closely related to birds. There's the T-Rex head. Giant, 5 feet long, and it looks massive. It looks real solid. But it's not. It's hollowed out. Nearly every bone of a Tyrannosaurus rex skull was penetrated by air ducts connecting to the lungs, exactly as in a bird skull, exactly. Down to fine details of where the nerves and blood vessels go, and these air ducts, Tyrannosaurus rex is a bird head. It's a bird brain and an airhead. You take your ostrich, get a chicken, maybe you're a pigeon, cut the skull away, and you'll see a ductwork just like that. So whether you're talking about overall resemblance or detailed plumbing, birds are dinosaurs, and your parakeet is a close cousin of Tyrannosaurus rex.
Well, now in the detective work, to get to this theory, which sounds perfectly plausible to me, but to get to that, from the middle of the 19th century, What's new? What has been added in the number of clues that bring you to the conclusion now that seems so definite?
Well, by 1870, they knew that some sort of dinosaur was the direct ancestor of birds. They really had a good case. They also knew it was probably a meat-eating dinosaur. But they didn't know which of the many meat-eating dinosaurs was closest to birds. What we've added in the last couple of years is it's the very advanced, air-conditioned meat-eaters like Tyrannosaurus or the little Troodon. Those are the guys who are very, very, very close.
But so really, in all these years that we've been talking about the extinct dinosaur,
Right.
we've just been wrong.
That's right. Dinosaurs aren't extinct. You can think of Tyrannosaurus rex as the 8,000-pound roadrunner from hell.
While meat-eating dinosaurs have their own evolutionary tales to tell, so too do the plant eaters. Living alongside Archaeopteryx, there were the giant dinosaurs like Diplodocus and Brachiosaurus. These were the first creatures ever to feed upon tall trees. To do this, they had to evolve extremely long necks.
This creature was able to reach very, very high up into the trees. The trees that grew at this time were primarily conifers. They were very tall, and most of the vegetation was clustered near the top. So this was an ideal way of reaching giraffe-like right up into the trees to actually crop the vegetation. It has very large peg-like teeth, which would have been ideal for scraping or nipping off small branches. It could be a very effective hoover-up of all the rubbish in the environment, in a sense, all the relatively indigestible twigs and pine cones and leaves and needles. They have a very complex digestive system. The stomach would be a large muscular sac, lined, in this case, with large, rounded, polished pebbles. These would be acting like a mill to pummel up the plant food. The teeth weren't designed to chew up the food, so it uses stones in its stomach instead. Once it's reduced the plant food to a mushy pulp, it's then passed on to another part of the digestive system at the back end. And here, there are like long cavernous tubes, and this mushy plant material passes into those tubes where it's mixed up with the bacteria, which then break down and produce the chemicals that allow the animal to live.
Against these giant feeding machines, the plants fought back. From their struggle to survive, a more varied and beautiful environment began to emerge.
Any large herbivore has a tremendous effect on the vegetation that it eats, and to tear down trees, to remove large branches and that sort of thing, that has an effect on the vegetation. It has an effect on individual trees, and it also opens clearings in the forest. And elephants act in that way even today. Large trees may, in a sense, not have any choice but to defend what they are. And so they would develop mechanisms of defense, for instance, spines or sharp pointed leaves, or perhaps chemical toxins that would deter those big herbivores. But if you're a small plant, a weedy thing that's doesn't have a very big body to begin with, it may be that it's much easier, rather than to try to defend that, to begin to grow very rapidly, to get through a life cycle quickly before you're eaten. So I think the first flowering plants may have fallen very naturally into a defense mechanism that wasn't so much a defense as it was an escape from herbivores, from the big dinosaurs that were after them.
The next wave of big plant eaters had short necks, fed close to the ground. One thing flowering plants do, better than any other type of plant, is they can spread rapidly and regenerate themselves after heavy grazing.
Near the end of the dinosaurs' reign lived centrosaurs in large herds. Thousands roamed the plains in search of food. Weighing 3 tons with sharp beaks and great powerful jaws, they wreaked havoc. Plants had only one defense: to blossom in profusion to survive.
And flowers just explode across the landscape. It's an incredible, the biggest event in plant evolution are the flowers coming in, and people have asked why. And I think the answer is dinosaurs invented flowers.
The evolution of plants and animals takes place over millions of years. One way to grasp such a vast time scale is to place Earth's history against a tall building, like the World Trade Center here in New York City. Earth's creation's at the ground floor. We're at the top floor. Dinosaurs first appeared a staggering 225 million years ago and ruled for the next 150 million years. They only died out 65 million years ago. We humans arrived only yesterday, 3 million years ago. Makes me feel quite young. You know, Paul, for all of our discoveries and detective work, we still know fairly little about the dinosaurs, how they lived, how they died. Perhaps if we discover all the answers, we'll find some clues that might guarantee our stay on Earth. Perhaps we will, perhaps we won't.
These birds migrate every year to the four corners of the globe, just like their dinosaur forefathers used to roam the entire world millions of years ago.
But if the dinosaurs dominated the planet for so long, why? Why did they die out? What happened? Let's look at the clues again to see if there's any hope of solving this mystery. In 1789, in revolutionary France, death and extinction were everywhere, not of dinosaurs, but a whole class of humans. As the guillotine wiped out the French nobility, one man watched the carnage and survived. The aristocratic Baron Georges Cuvier observed the calamity that had befallen France and applied it to the animal kingdom. In Earth's long history, had whole classes of creatures become extinct? From his laboratory full of fossils, Cuvier thought they had.
Cuvier was the first scientist to unequivocally establish the fact of extinction. It seems so basic now, we are amazed that it was ever doubted, but before Cuvier's time, first of all, some people thought the Earth wasn't very old, so that didn't give a lot of time for a history that would have included extinction. It was Cuvier who, by studying the anatomy, mostly of mammals, established without any doubt that there had been successive extinctions through time. Now, that may not seem very important, but if you think about it for a moment, you'll realize that without extinction, the Earth has no history that can be measured. If all animals were made at the beginning and nothing ever changed, you'd have no criterion whereby you could assess the age of rocks and establish a sequence of history. By establishing extinction, you make it clear that some creatures lived early, some lived in the middle, some lived late, and consequently, by establishing the fact of the sequence of extinctions, the Earth attains a history for the first time.
Cuvier painstakingly dissected living animals and compared them with fossil types. As a result, he had an encyclopedic knowledge of animals and was able to show that some fossil animals did not have any living relatives. They had simply disappeared from the face of the Earth. This detective work set the stage for Charles Darwin to establish a mechanism for evolutionary change, natural selection. Through this, he showed how species gradually replace one another in the struggle for existence.
The Darwin system provides a close and continuous tracking of environmental change. Environment changes and organisms change slowly and steadily to match those alterations. It gets colder, elephants grow hair, and you have woolly mammoths. That's slightly oversimplified, but there it is. Now, if that was all there was, then there might be a much more sensible pattern. Life would match environments. Much of evolutionary change would be progressive because you'd have animals struggling with other animals, and the ones that were biomechanically more efficient would eventually win. Everything would get better and would track local environments. The problem is that on top of that, you have these very large-scale environmental changes, the catastrophes of mass extinction being the best example, which destabilize that system and provokes sudden changes well beyond the capacity of any organism to adapt to it. Then many are going to die. just simply die as species. They'll be gone.
At the dawn of the dinosaurs was Solnhofen. Lively and intelligent, it was well on the way to establishing the reign of the dinosaurs. Ironically, no sooner had Solnhofen got a foothold than the species was wiped out by a catastrophe. But rather than sealing the fate of the dinosaurs, this event gave dinosaurs as a whole their chance to achieve supremacy on land. For long before dinosaurs died out, the rock record reveals an earlier, near extinction that killed off many of the early dinosaurs like Solnhofen. In Nova Scotia, the red rock is punctuated by a significant white line. It marks a catastrophic event. Below it, Solnhofen and other early dinosaurs have been found. Above it, Solnhofen is absent, but in its place are the remains of later, more developed dinosaurs. Here at this site, two dinosaur detectives believe they have the evidence to show how dinosaurs rose to conquer the earth.
At this white line here, we have basically a bookmark between two great chapters in dinosaur evolution. We see preserved here one of the four largest mass extinctions in the history of life on this planet. I mean, about 40% of the animal life that was on land quickly disappeared, became extinct. Well, here we have a large mass extinction. What you got to wonder is what's the cause? There are lots of ideas, but one that's very tempting to us is that this extinction coincides with one of the largest known asteroid impacts in the history of life. There are several different ways that it could bring about a mass extinction. Well, first you have this huge rock, which may be 10 to 20 miles in diameter, hitting the Earth at great speed. That's going to release a lot of energy into the atmosphere. And not only energy, but dust. And it's that dust that can block sunlight, that can interact with gases in the atmosphere to produce acid rain, changes in temperature, changes in the light cycle. It'll affect the creatures that are around directly, but it'll also kill what they're eating, so it'll cascade through the food chain.
After that catastrophe, within 10,000 years, a huge amount of lava poured out on the surface in this region. In fact, lava poured out from Nova Scotia to South Carolina, a huge series of lava lakes.
We have a very unique record of this large mass extinction. The reason why it's a unique record is because we're sampling from a whole wide variety of environments. We have fossil lakes, we have fossil deserts, we have fossil streams, and so we're sampling from the creatures that lived within those. And we're getting a very good idea of what the diversity of life was like, both before the extinction and after the extinction.
The evidence for survivors are found all over these cliffs. Specifically, we find lots of little bits of bone, pieces of jaw, pieces of skull and backbone, the creatures that survived. One of the first things we find are tiny footprints. This footprint probably belongs to a creature that looked like this, a small dinosaur no bigger than my hand. One of the typical survivors, a beautiful little animal, very graceful, almost bird-like. The other clues we found include these little bones. This is typical of the mammals and mammal-like reptiles that survived that boundary along with the dinosaurs. You have both forms. They're similar in size, they're similar in the fact that they survived the boundary, but for some reason, one group, the dinosaurs, becomes dominant over the next 150 million years.
The destruction that wiped out so many species allowed the best adapted dinosaurs to fill the void left by others. In all their rich diversity, they evolved and flourished.
The asteroid hits and produces a whole spate of environmental changes, and then some creatures make it and some creatures don't. But insofar as whether you make it or not is dependent upon features that you evolved for other reasons and not because you knew that an asteroid was hitting. In some deep sense, you get through a mass extinction by good fortune, but I don't mean that it's random in some technical sense. You get through for a reason, but the reason has nothing to do with why you evolved those features in the first place. So I think that would qualify in our ordinary language as good luck. And I would say, yes, most creatures get through mass extinction by something akin to what our language would call good luck.
One thing that may have been very important in the dinosaurs' success over the mammals was their wonderful adaptations for running. That's something which sets them apart, as you can see in these two reconstructions. The dinosaurs are built for speed and power. The mammals are built for burrowing and scurrying about. When you get very large, it's easy to do it from this basic architectural beginning, and much harder to do it from a mammal-like pattern.
The kingdom of the dinosaurs was the longest and most successful reign of any creature on Earth. Our ancestors, the mammals, lived in the shadow of the dinosaurs for all their 150 million years. They survived as tiny, shrew-like creatures living in the nooks and crannies of the dinosaur empire. The real question was not why the mammals did so badly, but why the dinosaurs dominated the Earth. The early extinction killed off the competition. In the struggle for supremacy, dinosaurs had one big advantage: strong, upright legs. The large Tyrannosaurus and Allosaurus combined power with grace for running and supporting a heavy body. The bigger and really heavy dinosaurs made little pretense at poise. Both Centrosaurus and Brachiosaurus used their legs like straight pillars to support the great weight of the body.
Evolution, in a sense, can be seen to be progressing very nicely through the fossil record, and then bang, everything goes extinct, or a large percentage of everything goes extinct. The timetable is then reset, in a sense, and then evolution carries on again and progresses and develops, and then it can be reset again by an event such as a mass extinction. The really intriguing thing is that these mass extinctions, it has been proposed, could be periodic.
Death from outer space is not just science fiction. In March 1989, the Earth came close to another global catastrophe. Not dinosaurs this time, but ourselves.
Now, direct from CBS News, this special report.
Reports of a large asteroid that narrowly missed the Earth in the early hours of the morning have just been confirmed. Dr. Harry Holt, the Arizona-based astronomer who identified the asteroid, said, "We are now out of danger, but it was a very near miss indeed."
How close did it come?
It came about 2 times the distance from the Earth to the Moon.
But that's considered pretty close.
That's very close. If it was much closer, it would be pulled in by the gravitational attraction of the Earth itself.
How much damage would that 89 meteorite have done?
A lot. An object of that size, traveling at about 25 kilometers a second, would hit the Earth with a force that was equivalent to about 10 to 100 times the combined US and Soviet nuclear arsenal. So it would be a very, very big impact.
That the dinosaurs died out 65 million years ago is not in doubt. What is in doubt is why. Just what killed them is today's hottest debate among dinosaur detectives, and there are many theories. Did the climate change? Were they too slow to adapt to evolution? Or, most intriguing of all, did something happen out there in space? Something so cataclysmic that it extinguished the dinosaurs, as it were, in a flash.
basic idea is that there was a 10-kilometer body of rock that hit the Earth at about 25 kilometers a second. That would yield about 100 million megatons of TNT worth of energy upon impact. And that's 10,000 times the combined US and Soviet nuclear arsenal. So the near hit we almost had would be minuscule by comparison.
Dinosaur detectives are in no doubt that an asteroid hit the Earth 65 million years ago. The question is, was it so catastrophic that it ended the dinosaurs at a stroke? Or was the impact just the last straw, a final blow on top of other changes in climate and environment that already had weakened and reduced the dinosaur empire? So far, the evidence is still being assessed, the verdict unclear.
We're here in the beautiful Badlands of eastern Montana, and in this area we have some remarkable rocks that preserve some real evidence for a detective story. One theory is that the dinosaurs died very gradually as a result of changing environments. And in this theory, during 5-10 million years, the environments changed so much that the dinosaurs could not keep pace, and they died out very slowly. Fewer and fewer kinds of dinosaurs were present. In this theory, as we climb from the bottom of these rocks up to the boundary layer, we would find fewer and fewer kinds of dinosaurs and fewer numbers of dinosaurs. There's another theory that the dinosaurs died very suddenly, perhaps in only a few years. And this theory holds that at the coal layer, there's a clay that was laid down as a result of the impact of an asteroid. And the cataclysmic events of this asteroid impact caused the very abrupt demise of the dinosaurs.
What I'm exposing here is an ancient coal deposit, as you can see down here along this black layer over here, and coming in the center of this coal deposit is this very distinctive white clay layer. This white clay layer contains, we believe, the remains of material that came from extraterrestrial sources, iridium and shot quartz, and these materials are thought to have come from a source that is not on Earth, but rather from the impact of an asteroid with the Earth. And so what we think is, because we never find dinosaurs higher than this level of clay, but we find dinosaurs all the way to this layer of clay in time, what we believe is that this layer of clay has something to do with the demise of the dinosaurs.
Dinosaur detectives had, by 1980, collected a mass of clues that pointed to a catastrophe from outer space. What was missing was the final proof. Then, 10 years ago, Walter Alvarez claimed he had found the evidence that clinched the debate.
Alvarez didn't introduce the first extraterrestrial hypothesis. There have always been extraterrestrial hypotheses, but in the past, they were in this curious scientific limbo. That is, they were perfectly plausible, but there was no evidence for them. What good is a plausible theory for which there's no recorded evidence? The importance of Alvarez is not that he has a meteorite or an asteroid or a cometary scenario rather than a supernova scenario. It's that he found this iridium level and for the first time gave us something we could test scientifically for catastrophic mass extinction.
Walter Alvarez has found a layer of clay in the rock record that is saturated with iridium. It should not be there. Iridium in that concentration, he claims, could only have come from outer space. Here, he says, is the final proof why dinosaurs died out. Their world was extinguished by a calamity, immediate and devastating.
Well, what it tells us is that the killer was a large rock falling from the sky, a very large rock, something maybe 5 miles in diameter, something like that, falling at a very great speed, landing on the Earth and causing a variety of really terrible environmental disturbances, the result of which was that dinosaurs and many different kinds of shelled animals, plants, microscopic animals and plants in the ocean perished. The iridium was the first evidence we found that the Earth was struck by a large object, comet or asteroid 65 million years ago. But in the 10 years since that have followed, a great deal of confirming evidence has been found of various kinds. For example, the same clay layer that contains the iridium also is full of little tiny drops of rock matter that were originally little droplets of molten melted rock, melted by the heat of the impact and then dispersed around the world, and they have fallen to Earth after the impact. We find those all over the world. Lots more lines of evidence, various kinds of technical things, all confirming the conclusion that a large object struck the Earth at exactly the time the dinosaurs died out.
The sudden impact theory has not convinced all dinosaur detectives. The clues in the rock record are, for some, still too uncertain to close the file on the death of the dinosaurs.
Is there evidence to connect the Iridium with the disappearance of the dinosaurs? And I am not convinced. Now, the scenario suggests that on a Tuesday afternoon, the sun was shining and the dinosaurs were just as happy as can be, and by Wednesday morning, the plain was dotted with these green lumps of putrefying flesh, and the mammals were scurrying around enjoying their prosperity. But the problem is the fossil record cannot distinguish between an event which happened between a Tuesday night and a Wednesday morning and an event which took 10,000 years to occur. And there's a world of difference between these things.
Sudden death from an asteroid, or were dinosaurs already on their way out? After 150 million years of their reign, the climate already was changing, favoring our ancestors, the mammals. Some think the scales already had been tipped against the dinosaurs before the meteorite struck.
In these boxes now are the clues as to who's still around, who's not, who's in the local economy, who's not. These are our clues. This is where we make our census count. This is what determines who is present, who is not, who is expanding, who is going extinct. What we have found now is that there is a decline in dinosaur populations that begins well in advance of the asteroid impact layer. The mammals, at the same time as the dinosaurs decline, the mammals increase. Neither of these observations are consistent with a sudden extinction event.
Whatever the cause, the extinction 65 million years ago left a void. With the end of the dinosaurs came a new opportunity. Out of the hole left by the Holocaust came the little mammals.
If you want to argue, it's plausible that mammals got through and dinosaurs didn't, because mammals were small and smallness conveys advantages. They weren't small because they knew a mass extinction was coming. Presumably they were small for negative reasons, because dinosaurs dominated the environments of large-bodied creatures.
And what about the large reptiles that are still around today? How did they survive this mass extinction?
We often wonder why we have such nice tortoises these days, which are still here, our big reptiles. What happened to the dinosaurs? Dinosaurs may have had a problem with sex. A problem with sex in the sense that they probably had temperature-dependent sex determination, like modern reptiles. Most modern reptiles, the temperature of the egg determines the sex of the hatchling. A warm turtle egg gives a female turtle. A cold turtle egg gives a male turtle. This tortoise, it's a male. It came from a cold egg. In the case of lizards, a warm egg makes a male. So now if you could picture dinosaurs migrating away from the ocean side or migrating up to the highlands to lay their eggs in colonies, the climate getting colder and more seasonal, the dinosaurs would have perhaps produced all males in a cold climate. All males would lead to extinction of dinosaurs.
The sex of dinosaur offspring was determined not by the chromosomes of the parents, but by the temperature of the eggs in the nest. And if the eggs were cooling, it is possible that the sex ratios of the offspring were shifting from a 50% male-female ratio to a 75-25 to a 90-10. That may have entirely upset the population structure of dinosaurs. And the last dinosaurs on Earth may have been disappointed males.
Well, turtles and alligators and crocodiles live near water. And if you live near the water, a large lake or an ocean, or if you live near a big river, the climate is more moderated by the water. So a moderated climate with moderate temperatures for the eggs allowed them to survive.
Too many clues may in the end point in too many directions. We may never know for certain what caused the death of the dinosaurs, but one conclusion has been agreed by all detectives, that Earth's history has been punctuated by great extinctions since the beginning.
We don't know how regular mass extinction is, but we certainly know that there have been many of them, and that several have been larger than the one that wiped out the dinosaurs. We focus on the one that wiped out the dinosaurs for two reasons. First, we have this enormous parochial interest in it because dinosaurs died and mammals survived, and that's why we're here. Secondly, it's the most recent of the major mass extinctions, and therefore the evidence is better.
Extinction and evolution, which brings us back to Archaeopteryx and its feather, where our story began. All dinosaur detectives agree that in looking at the clues, especially whether dinosaurs survive as birds, requires a great deal of imagination. We try to visualize the world of 200 million years ago, how the dinosaurs lived and how they might have died out. But if we, as it were, imagine forward, fantasize millions of years from now, is it possible, is it just possible, that the most successful species ever might, as we say, stage a comeback?
Standby studio, coming to record. Standby Walter on the floor. VT, let's get it together, please. Standby studio, standby Walter.
Counting in 10, 9, 8, 7, VTRB, Q-tape.
Coming to camera 4 first.
3, 2, 1, 0.
Take 4 and Q Walter.
Good evening and welcome to Dinosaur TV and the final episode of our history of life on planet Earth. Even after investigating dinosaur extinction, those clever humans were unable to foresee their own downfall. Their pollution led to uncontrollable global warming, and in the panic, humans fought humans, producing a nuclear holocaust. Few survived, just those lucky feathered dinosaurs, our ancestors, who migrated to the safety of the polar regions. Over time, we recolonized the land and lost our feathers. Dinosaurs were back in control at last. Fantasy, of course. We humans are still here. We're still in control. But curiously, people everywhere are becoming uneasy. For the more that we appear to master first the Earth and now space, the more fragile our planet becomes. Ours is but a short-lived conquest of this Earth, and while we loftily investigate the dinosaur empire and its fall, perhaps there is revealed in its long, long history an humble truth that our existence is but a flicker, a blip in the history of life on Earth. Whether we rival the magnificent record of the dinosaurs, well, only time will tell. But for now, that's the way it is.